Good morning. This lesson is for my Integrated 1 class, but before I get started, I want to say I hope that everyone is doing all right out there. I'm not sure how I'm going to title it, but when I title it in the title, that's how I'm going to title it. But what I am sure of is our one goal for today. And our one and only goal is going to be to use a folded piece of paper to reflect figures over a line. This is our third rigid transformation. And I would like us to again physically go through the process of doing this so we get hopefully a better conceptual understanding of what a reflection is. And let's just go ahead and jump right into our first goal. A reflection is a flip of a figure over a line. So for example, if I have my hand here, I can flip it over this line of reflection. Or if I start over here, I can flip it and go over there. I'm not going to get too much into the details about reflections. We'll get into that a little bit more in the next lesson, but this is more of an exploratory lesson where we're just understanding what's physically happening when we reflect objects or figures over a line. And like the previous two lessons, it would be much better for you to hit pause right now, write down the directions, and as I work on an example from above, I will read the directions to you and hopefully they make a little bit more sense. So why don't you go ahead and hit pause, write down the directions that I'm looking for, write down the directions, and then we'll go ahead and move on to the next part of the lesson. So I'll be back. All right, I'm back. So I'd like to go ahead and demonstrate to you how we're going to reflect a shape over a line of reflection. So again, I have a piece of paper that I'm going to fold. I have the paper that I'm going to draw my figure on and reflect over, and my pen. All right, so I was thinking about this, and I think we want to go hamburger hot dog fold, because I think that that's going to make it a little bit easier to reflect, and you'll see why here shortly. Okay, so I made a hamburger fold, but now I'm going to hot dog the hamburger fold. And now I'm left with something like this. Okay. And you know what? Maybe I will just add one more fold. We'll go three fold. Okay, so now I have a straight edge that I'm going to draw my four-sided shape. And again, I'm using a four-sided shape because I believe that will allow us to really see the behavior of the reflection and notice some things about the shape as it's reflected. So let me go ahead and draw my four-sided shape. And I want to make this a very distinct four-sided shape so it's very clear the parts of the shape as it's getting reflected. And I'm going to label points on this as well. So hopefully that's nice and clear to you guys. This is vertex A. This is vertex B. Right here is vertex C. And finally I have vertex D. Alright, so there's my four-sided shape. And I'd like to draw a line of reflection. So now let me get into the directions here, because again, that's not a very good letter. Again, if you see the directions, they're not going to make sense unless you see them in action. So let's go ahead and jump into that. So steps to reflect a figure over a line. This is my figure. I want to reflect figure A, B, C over a line. So using the folded paper, draw a line you want to reflect over. All right, I would like to reflect over a line that looks like, I want it to be off a little bit. I want to reflect a line like this. So this is going to be my line of reflection. And I could have drawn it or oriented it in any way, but I chose to orient it this way. So I want to flip this shape over that line. Again, like my hands in the opening section, it's going to flip over. Okay, so I drew the line that I want to reflect over and then fold the other paper on that line. So this is my third attempt. And it's kind of hard to fold the paper on this line blindly. So what I realized is it's actually a little bit easier to fold the paper on the line in the opposite way, because you can see that fold pretty clearly. And then you can go back and fold it the other way. Now, the reason why we want to fold is we're going to use the fold as a guide. It's going to help us to flip over this shape perfectly over the line. So again, I wanted to fold that. Let me fix that little kink right there. Come on, I can beat this. I need to be rock and beat this paper. Okay, there we go. All right, so I've drilled my line I want to reflect, and I folded the paper at that line. And again, this fold is going to help me here. All right, on to step 2. Second, unfold the folded piece of paper. Place the fold of the folded paper on the line of the reflection and mark the links to the vertices. So here's my folded paper, my hamburger hot dog hamburger fold, right? I'm going to unfold it, and I'm going to place the fold of the folded paper in the fold of the line of reflection. And this is accomplishing something very important for us. And what it's doing is it's making sure that the distance is the shortest distance from the line of reflection. So it actually is making a right angle. And we'll get into that more when we do the math behind the reflection. But again, this is just a lesson on physically doing a reflection so you understand what the process is like. So again, place the fold of the folded paper in the fold of the original piece of paper. It's a tongue twister. And mark the lengths to each vertice. So here's the length to vertice A. I need to slide up my folded paper a little bit, make sure the fold is in the fold. There's my length to B, vertex B. Just keep this in there. There's my length to vertex C. And of course, this is right there. There's my length to vertex. Let's make that a little bit longer. Vertex D. Okay, so I completed the second step. Did I do that one right? Yeah, I did. Okay, good. All right, so the third step says rotate the folded paper 180 degrees. Okay. And place the fold back on the line of reflection. Line up each vertex and mark the links from links from step 2 on the other side of the line of reflection. Connect all the new points. So I'm going to go back and I'm going to line up my folded paper with the line of reflection. This one's a little tougher because we're going off of it and I can't line it up perfectly, but I'll try my best to line them up. And let's see here. That looks pretty good. So it looks to me this is where point A is going to be. It looks to me this is where point B is going to be. Let me put that there. That's actually B prime. And there's my A prime. Because I'm in the image now. Line this back up with point C and my fold. There's my point C, or C prime, I'm sorry, keep making the same mistake. And line it up one more time with vertex D, or point D. And there's my D prime. Okay. And so the last thing on step 3 is I want to connect the points. Now, if I did this correctly, I should have repeating lengths, meaning the length from vertex A to the line of reflection should be the same length as the length of A prime to the line of reflection. The same thing would be true for B and B prime. They're the same distance away from the line of reflection, as well as C and C prime. They're the same length to the line of reflection. And finally, D and D prime should be the same length to the line of reflection. But again, you can see that by following these steps, I was able to take my shape and flip it over. And again, these are just exercises in you physically experiencing the concept of reflecting an object. And try your best to make it, as accurate as possible. I know we're a little bit limited because we're using some rudimentary tools, but again, the concepts are going to be there, and it is important to actually go through the process. And I want to just show one more thing. Hopefully, I'm not off with my claim that the length from A to the line of reflection, or maybe I should use centimeters on this because it's a smaller length. The length from A to the line of reflection, which is 2 centimeters, is the same as the length from A prime to the line of reflection, which is again 2 centimeters. The length of B to the line of reflection is 6.5 centimeters, and the length of B to the line of reflection again is 6.5 centimeters. It should also be the same length from C to the line of reflection, which is 5.5. And again, I'm a little bit off on C. That's about 5.4. That's so embarrassing. And the length from D to the line of reflection is about 5.9. And D prime, that's right on the spot, 5.9. So these lengths, they are the same. And it makes sense because it is like a mirror, as your hand gets closer to a mirror, the reflection's hand gets closer, and when your hand touches the mirror, your reflection's hand touches the mirror as well. So I'm going to go ahead and go back to the whiteboard, wrap this lesson up, and I will be back. I'm back for the last time, I promise. So let's go ahead and just wrap up this lesson. And again, I wanted this to be an experience of you physically reflecting a shape or a figure. So let's continue and wrap this up. We now have physically translated, which was to slide, rotated, which is to spin, and reflected, which is to flip figures. In future lessons, you will be asked to do a sequence of these transformations. For example, you may translate, then rotate. You may slide, then spin. Or you may reflect, rotate, and then translate. So flip, spin, slide. We are going to combine these ideas. That's where the lessons are headed. So again, I wanted you guys to physically do this so you got a better conceptual understanding of what rigid motions or translations are. And I think I'm going to go ahead and end this here. So again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.